Okay, that will act as a catalyst. Catalyst means it also increases the speed of reaction, but it will not participate in the reactant. It will not. It combines with the reactant. After that, once product is formed, means it will be separated. Understood? Suppose iron oxide, platinum, these are all act as a catalyst. Okay, iron is used as a catalyst in Haber process. Platinum is used as a catalyst in வெயிட் பண்ணுமா அப்படி நோட் பண்ணிங்க, நீங்கள் எழுதிட்டே இருங்க. அப்படி ஏம் போட்டு mechanism of the reaction. Okay. Okay. These are the important factor: temperature, pressure, catalyst. Apart from that, we have what? Surface area. Surface area of the reactant. Surface area of the reactant. So, if you take the substance in very powdery, means it will react. Suppose we are taking the substance are very bulk amount. Instead of this, or if you take the substance in solid state, it will not react properly. But the same substance, if you take in powdery form, it will react more. Understood? If the substance in powdery form means its surface area will be somewhat increases. So surface area of the reactant, catalyst, pressure, temperature. Okay, these are all very, very important to increase the speed of the reaction. Understood? So this is not only we are going to study in this chapter. Okay. Then mechanism means some same reaction. It will take 2 or 3 steps. Understood? For getting the product, it will take 2 steps, 3 steps. Okay. So that this is called, we can say, mechanism of the reaction. Understood? Are you following? Okay. For example, you studied in organic chemistry. Ethene to ethanol, we have 3 steps to get the product. Understood? So that's called mechanism of the reaction. Okay. What are the steps involved in the reaction? That's called mechanism of the reaction. That's the aim. Our aim to what is the important scope of this lesson means rate of reaction and mechanism of the reaction. This only we are going to study. Understood? Okay. Just note down this only. Rate nothing but speed of the reaction. That's all. Simply remember. Okay. Speed. If you want to increase the speed of the reaction, what are the conditions you should follow? Okay. So these are all, generally, temperature, pressure. If you apply temperature or if you apply pressure, automatically the reaction is going on very fast. Understood? Okay. Understood? Okay. This is the aim or this is the scope of this lesson. Understood? Okay. Now, as usual, we are going to study about some important terms in this lesson. First, that's why you put the terminology. You put terminology. Terminology in chemical kinetics. Okay. What are the important terms we're going to study? Understood? So first term is, see, then you can write, listen, rate of reaction. Rate of reaction means here we are giving one definition for that. What is the rate of reaction means? Suppose here change in concentration of reactant or product. Understood? Reactant or product with respect to what? Time. That's a definition. Okay. Suppose, if you take reactant is going on, changes. Suppose if you take 100 gram, understood? But whenever the reaction takes place, what happens? It goes on, it's a reactant, it's a product. Understood? Whenever reaction going on, what happens? 100 gram goes on, decreases. Whenever reaction going on, 100 gram is not present as it is layer. Whenever reaction going on, the 100 gram is going to becomes reduces. Which one increases? Okay, when the reaction takes place, concentration of the reactant decreases, concentration of product increases. There is some changes taking place. Whenever that's called rate of reaction. Change in concentration of the reactant or product with respect to time. When the time increases, some changes will be taking place in reactant side as well as product side. That's called rate of reaction. Understood? Are you following? Okay. So rate of reaction means this definition they are giving. Okay. Change in concentration of the reactant or product with respect to time. That's called rate of reaction. Okay. Then suppose here, what is the unit? Unit of rate of reaction means what? Here concentration, no. Concentration means, mole per liter. Mole per liter. Understood? Time means what? Second. Mole per liter per second. That's the unit of rate of reaction. Understood? Suppose here, mathematically outright means, suppose for examples, give an example. So suppose H2 plus Cl2, 2HCl, simple reactions. Outright the rate of reaction for this reaction means, rate is equal to, I told you, left hand side goes on, decreases. Right hand side goes on, increases. No. Decreases means we use minus. Okay, each and every reactant, every species we should write the rate. Okay, so here d by dt concentration of H2. Are you following? Then it is equal to, we don't put plus symbol, each and every species we should write. It is equal to minus d by dt concentration of Cl2. Understood? Here goes on decreases, yeah, then only I put minus. Right hand side you put plus. Okay, plus. Then one more condition is important. See, here what is the coefficient? 1. They are saying divided by its coefficient. Here 1 by 1, leave it. 1 by 1, leave it. But here what's the coefficient? 2, no. Divided by its coefficient. Okay. Divided by coefficient 1 by 2. Understood? Here 1 is there, no. 1 means here, don't worry about that. Okay, 1 by 1 means leave it. Need not write. Here 2 is divided by its coefficient. Okay, that also important. Just remember, divided by its coefficient. Are you following? Then d by dt, concentration of HCl. Are you following? Okay, I'll give one examples. You can able when you write the second examples, you can able to understand this one. Okay, just copy them. Write fast. First important term is left hand side goes on decreases whenever the reaction proceeds. Then only I put what? Minus. Right hand side, concentration of the product will be increases. Then only I put plus. If any coefficient means divided by its coefficient. That also important term. Divided by its coefficient. This is a way to write rate of reaction. Understood? Any doubt means ask me. Change in concentration, okay, of the reactant or product with respect to time. This mathematically we are writing like this. D by dt means, mathematically you know that mathematical term is d by dt. The meaning is called change in concentration with respect to time. T is for time. Okay. So mathematically we are writing like that. D by dt, just remember. Okay. Finished? What is the unit? Unit, put it box. Unit is what? Mole per liter per second. Understood? Okay. I'll give one more examples. You write H2 plus 3, N2 plus 3H2 gives what? 2NH3. How to write the rate of reaction? Rate is equal to what? Left hand side always you put minus. Then before that you check whether it is balanced or not. But it's a balanced equation. Yeah, mostly they will give only balanced equation. Tell me. Minus? Coefficient is only 1, no? So leave it. d by dt, concentration of N2 plus, not plus, is equal to 3. Minus 1 by 3, d by dt, concentration of H2. Plus, no? Right hand side you put plus 1 by 2, d by dt, concentration of NH3. Understood? Okay, right. Okay. You following? Okay. So based upon how they will ask one question means, suppose they will give everything. Okay. So this is called formation of ammonia. In this formation of ammonia, they will give the equation mostly. Okay. But they are not given means you must know. Ammonia means NH3. How it is formed, N2 plus H2 gives 2NH3. Okay. First of all, you write the rate of reaction. Okay. Suppose here that is, you write the rate of reaction, they will give any one of the values. Suppose here this value is given. Suppose rate of reaction of rate of formation of ammonia is given. For example, this is this is 0.2. I simply write. Okay, understood. What is the rate of reaction they will ask? Okay, so suppose here you just compare. Just compare this one. These two only you just compare. Okay, the value is given means 1 by 2, no? So here just multiply. This value is given means here you just substitute. What? The rate of formation of ammonia is 0.2 molarity. What is the rate of reaction? The loss. Okay, so you just substitute here. We are plus 1 by 2 into 0.2 what? That's my lemma. Understood? Both the same multiplied by? Both the same multiplied by what? 0.2 by, how to simplify? Tell me, both the same multiplied by 10 means what? 2 by 10. This is what? Again? 0.2 lama. 0.2 by 2. Then you multiply both the sides by 10. So it will be 2. This will be what? Again, understood? So what? Now 1 by 10 means what? Kata 0. Okay, so here suppose this is given means, suppose here the rate of rate of decomposition of H2 is, this value is given means you substitute here. Suppose here substitute means here 3 will be there. Understood? So the value divided by 3 you can get an answer. Understood? Okay. Mostly they will ask one equation is given, outright the rate of reactions. Okay. This is the first term. Understood? Okay. What's the next one means? Next term is rate average or average rate. Average rate. I'm going to teach both second and third. You put like that. Instantaneous rate. Instantaneous rate. Okay. You have another term. Simple one. See, rate of reaction can be calculated during the time interval. Suppose one reaction started at 9 o'clock. The reaction is completed at 1 o'clock. how much speed the reaction is going on. Okay, so during the time, what's the concentration at 9 o'clock? What's the concentration at 1 o'clock? So if you know means we can able to find out the average rate. During the time interval, if you are finding means that's called what? Average rate. Instantaneous rate means at particular instant. Suppose at 11 o'clock, what's the rate of reaction in between? Understood? At 11 o'clock, what's the rate of reaction? Particular instant, if you are finding means that's called what? Instantaneous rate. Okay. During the interval, if you are finding means it's called average rate. Okay. Just write. I'll give one definition. First write average rate. Okay. Rate of reaction can be calculated during the time interval. That's all. Rate of the reaction can be calculated during the time interval. Rate of reaction can be calculated during the time interval. Okay. Are you following? Suppose here one formula is there. Rate average. Rate average is equal to, I told you, no, if you know the initial concentration, if you know the final concentration, if you know the initial time, final time, then we can able to find out the average rate. This is a formula. We have one formula, minus of C2 minus C1 by T2 minus T1. This is a formula. Understood? This is a formula for that. Okay, just note down. C means concentration. Final concentration minus initial concentration. Final time minus initial time. That's all. Okay, it's a formula. Okay, now come to right hand side. Rate of reaction can be calculated at particular moment. At particular moment. It's called instantaneous rate. Rate of reaction can be calculated at particular moment. I told you, at 11:10, what's the rate of reaction? At 12, in between, here between during the interval only we are calculating here particular moment. Okay, that's called instantaneous rate. Understood? At particular moment, if you want to find out how much speed reaction is going on means that's called instantaneous rate. Understood? Formula, both are having same formula. You just write. Only one difference I'll give. Just write instantaneous minus C2 minus C1 by T2 minus T1. Same formula. Same formula, but only one difference. You just write after that, write. It is calculated by graphical method. That only mentioned here. It is calculated by graphical method. All these values we are getting, here the values they will give, but here value we are getting from only graph. Okay, then only it is calculated from graphical method. That only mentions enough. You following? Okay, sure. Simply I'll give one sums to you, so easy one. So then only you can able to understand this one. Okay, just write. Just write one problem, simple problem. Okay. Calculate average rate. Calculate average rate of the reaction when the concentration of the reactant changes from changes from 0.3 molarity to when the constant of reactive changes from 0.3 molarity to okay. Zero point 0.14 molarity. During the time interval is 25 seconds. During the time interval is 25 seconds. Okay. Oh. What's the question? Calculate average. Yeah. Okay. So C1, what C1, what C2? Time, sometimes only one time interval they'll give. Suppose then only we consider initial is what? 0. For the reaction, the whole reaction completed, how many seconds it's taken? 25 seconds. The whole reaction, 25 seconds taken. So initially considered 0. Okay. Finally is considered as 25 seconds. Understood? Then T1, T2. Understood? Okay. Right. Okay. Put that. If you know all this, you can substitute here. We can get the answer. What's the initial concentration?
0.
The textbook. First volume. Initial concentration what? 0.3. To what? 0.14. Okay. Initial time is you consider 0. It's not given means you consider 0. You get 25 seconds. That's all. Substitute. You get the answer. Understood? So rate average is equal to minus of CT is what? 0.14 minus 0.3 by T2 minus 25 minus 0, no? 25 minus 0. So automatically small number minus big number, no? Okay. So here also minus will be coming, outside on minus it will be plus. Understood? 0.1 0.167 0.30 0.1 for correct or not?
0.44.
6
Add the next number.
substitute. First you subtract. Okay, understood. Then again already on minus, no, it will be positive value. Okay. It will be subtract. 0.14 minus 0.3, no. Okay, small number minus big number. So here first you subtract. Okay, what's the answer? 6, here 2, no.
0.16.
0.16, but it will be minus, already minus. Outside on minus is present. Understood? So 0.16 by 25. Okay. So if you simplify, you can get the answer. That's all. Understood? Okay. This also you multiply. How to simplify? 16 into 10 power. Or you multiply. You multiply both the sides by 100. Palama. Okay, so here 16 by 25 into 10 per 100, no? Okay, you know that suppose here when it goes numerator, it will be what? I am writing the 1 by 25 only outright 0.04 into 16. When it goes numerator, it will be what? 10 power minus 2. Okay. Then if you multiply all this, you can get an answer. Okay. So method only, just remember. Okay. Understood? Actually, initial constants will be high. Are you following? It goes on decreases, Leah. The final constant will be somewhat less. C2 minus C1, no. Okay, already one minus inside. Outside we have minus, automatically it will be plus. Understood? Okay. The formula only just remember, it's enough. Okay? Are you following? Okay, this is simply, remember, during the time interval, if you calculate means average rate, at particular moment if you calculate means called instantaneous rate, that's all. Simply remember, okay? Another one is, no, fourth term, no? Fourth term, correct or not? First we studied rate of reaction, next one is average rate, next one is instantaneous rate, okay? Next one is, rate law. The term only somewhat different, but just try to understand, okay? Rate law nothing but, suppose, that A plus B gives AB, generally. So reactant is a product. Outright rate means rate, see, rate of reaction different from rate law. Rate R is equal to, so see, generally, the rate of reaction depends upon reactant only, always. If the reactant is very good means, or highly concentrated means, automatically the reaction going on very fast. So rate of reaction directly proportional to concentration of the reactant. Are you following this one? If I put one more C also means C I put here. D also I put here. Okay. So rate of reaction depends upon product of concentration of reactant. Understood? The rate of reaction depends upon only the concentration of reactant only. Understood? Okay. That's called rate law. Rate law nothing but this is the way to explain. Rate of reaction is directly proportional to product of concentration of reactant. Understood? Another term I'm going to introduce, that's called, fifth one is called rate constant. What is called rate constant means, you put one proportionality constant, R is equal to K into concentration of A into concentration of B. This K is called what? Rate constant. Or we can say it's called specific reaction rate. Specific reaction rate. Other name. Understood? Okay. Or it is simply, you can say it's a constant in rate expression, or it is a proportionality constant, or we can say specific reaction rate. So many names are there. Understood? Okay. See, then one more definition for this they are giving. Suppose when R is equal to K, when R is equal to K, because this term is what? When R is equal to K, this term is what? 1, no? Are you following? When the concentration of the reactant is 1, rate of reaction is equal to rate constant. Are you following? Okay. When concentration of A, concentration of B is equal to what? 1. That time only R is equal to K. This is also just right. This is the definition they are giving. It's the fifth term. Okay. any reaction is given, we can write rate. So that's any reaction is given, we can write rate law. It's called rate law. Beginning we studied, no, that's called rate of reaction. That is different. Okay. Okay. Understood? Another one is another very important. You make it a difference. 6th and 7. Is correct or not? Order and molecularity. Order and molecularity. Okay. Order. Order means here simply I am saying that, A plus B gives AB. Outright rate law. R is equal to K into concentration of A, concentration of B. No. Here we have some powers will be there. The powers we don't know. But X, I put Y here. Okay. So order nothing but X plus Y is called order. So we don't know the number. It's a 100% experimental quantity. What's order definition means? Sum of the powers of the concentration terms in the rate expression. Okay. Add the powers in the concentration term. It's called what? Order of reaction. Are you following? Okay. For example, I'll give. Okay. Suppose R is equal to K into concentration of NO power 1, concentration of O2 power 2. What's the order? 3. Add the powers. Understood? So order nothing but here order is equal to what? 1 plus 2. That is what? 3. It's a third order reaction. Okay. So they will give the value. You just add the powers. Okay. That's called what? Order. It may be minus also. It may be fraction also. Anything it will be there. Okay. That's called order of reaction. Suppose here if I put R is equal to K into H2 1 by 2 Cl2 1 by 2. What's the order? Half plus half. 1. Are you following? Okay. Just write. Definitions. If you know this, you can easily understand the definition. You just write. Order means add the powers. Simply remember. Okay. Add the powers in the concentration term. You following? Definition and all they will not ask, don't worry. But you must know the definition short way. Okay, order. What is order? Add the powers. Understood? It may be a fraction or it may be minus. Okay, whatever it may be. Okay, just write. Following. Follow பண்ணிங்களா? Okay, right. Simply remember like this, add the powers. Okay. So sometimes it may be order, I told you it's it's a definition. Add the powers, that's called definition. Second point is, it is a experimental quantity. 100% we can say, if you want to find out means, we can find out only through experimental quantity. Okay. Then it may be what? Its value may be what? 0. This also just note down. Maybe 0. It may be fractional or integer. Okay, anything. Okay. So just remember. If you get 0 means 0 order reaction. If you get 1 means first order reaction, like that going on. Okay. If you get fractional order reaction, okay. This one is remember is enough, okay. See here, now come to right hand side. Write fast, maybe 0, fractional or integer. Okay. Now come to the right hand side here. Molecularity. It's simply I told you add the powers. That's all. Order. Yeah. Molecularity means here number of molecules taking part in the elementary step of the reaction. How many molecules are involved? Suppose for example, you know how many molecules are involved? 2. Yeah, it's a theoretical concept. Theoretically, we can say, so how many molecules are involved? This is one molecule, this is one molecule. So 1 plus 1, 2. So in this reaction, molecularity is what? 2. Understood? Okay. Just write write the definition. Number of molecule taking part in number of molecules taking part in elementary step of the reaction. Elementary step of the reaction. Understood? Just write on examples. In this reaction, molecularity is what? Molecularity is what? 2. Okay. It must be balanced, okay? It must be balanced and then only we can able to find out, okay? Now come to the second point. Tell me, what is that? This is called experimentally quantity. That's what? Theoretical. Theoretically, we can say, one equation is given means we can say, okay, theoretical concept. You following? Okay. Come to the next, third one. Is it 0 value? Is 0 molecule participating? No, nothing, Yeah. Order may be 0. Sometimes 0 means it depends upon sometimes factors. Even though, suppose for example, in this order, H2 plus Cl2, 2HCl, okay. Even though we are taking the 2 molecule, H2 plus Cl2, the reaction will not taking place. When the reaction takes place means in presence of what? What is this? Light energy. When you apply light energy, then only the reaction takes place. But before that, no reaction takes place. Okay. So the reaction speed depends upon what? What? Only light energy. Without light energy, the reaction will not taking place. So, understood? The same reaction, you just compare the reaction. In this reaction, order is what? It does not depends upon this one. Okay, even though we are taking more concentration of H2 and more concentration of Cl2, the reaction will not taking place. Whenever if you apply some light energy, that time the reaction takes place. Understood? Are you following? Okay. So in this case, order is what? 0. That case, order is what? The same reaction. The same reaction, molecularity is what? 2. Molecularity we can get only from theoretically. When equation is given means we can say this is the molecularity. Okay. But order can be predicted only from experimentally. Understood? Okay. Just write the examples. Are you following? Okay. Molecularity never be 0. Next one, right. Molecularity never be 0 or fractional. It's quite opposite to that of this one. Okay. Never be 0 or fractional or integer. We have at least one molecule taking part. Understood? One molecule, two molecule, three molecule, like that. Okay, it never be 0. You following? Done. That's all. These are the important terms. Okay. Then one more step, one more thing you write. How many terms we write? 7. No. Okay. One more term. Rate determining steps. Rate determining steps. Simply write, suppose I told you mechanism. Suppose, for example, C plus half O2 CO. CO plus half O2. For getting CO2, how many steps it has taken? For getting CO2, it has taken what? 2 steps, no? 2 steps. C plus half O2 CO. CO plus half O2, again we get CO2. We have, this is called, step 1. This is called what? Step 2. So we have so many steps are there. Among the 2 steps, anyone will be going on very slowly. That slowly going on step is called what? We can say what? Rate determining steps. Okay, understood? So it may be first or it may be second. Okay, it depends upon the reaction. So what is that means? Rate determining step means what? Slowest step. Just write. Simply write. Do not write fully. Slowest step. Slowest step. Okay. Suppose here this is going on slowly means this is called, you can say what? RDS. RDS means what? Rate determining steps. Okay. Suppose this is going on very slowly means this is called RDS. Okay. Maybe so we have organic chemistry also, we have reactions or mechanism reactions are there. Okay. Suppose we have 3 steps are there. Anyone will be going on very slowly means among the 3 or 4 steps, one steps will be this one step will be going on very slowly. That is we consider as rate determining steps. Okay. Just remember slowest steps among the other steps of the reaction. This is called rate determining steps. Okay. This is another term. So these are the important terms in the chemical kinetics. Okay, understood? Okay. Are you following? Okay. Now we have, the topic is we have only first order reaction, zero order reaction, pseudo first order reaction, then Arrhenius equation. We have only 4 topics. So if you complete all this means the chapter will be over. Then we have to see some problem. Problem is very important. Then only, so compulsory one problem or 2 problems they will ask. Okay. Mostly we can expect only problem, not theoretical. Okay. So in physical chemistry we have 12th standard, we have 4 topics. In these 4 topics, we can get at least 2 sums each and every lessons, I expect. Okay. See, you put the heading, first order reaction. Zero order reaction. I give all the points, make it a difference. Make it a difference, first order reaction, zero order reaction. What is first order reaction? Order is 1. Simply we can say no. Order is 0. That is one way to explain. Okay. Or the rate of reaction depends upon concentration of one reactant only. Okay, you just write. First you must know the definition. Just write. Rate of reaction depends on concentration of one reactant only. Concentration of one reactant, understood? Reactant only. Understood? Okay. Example, just write example. So mostly all the decomposition reactions also considered as first order reaction. All the decomposition. See, so I'll give one example. See, decomposition of what is this? Hydrogen peroxide. Only one reactants are involved. Okay, so you know when it decomposition, what is the H2O plus cut or not? Mostly all the decomposition, only one reactants are involved. So mostly all the decomposition reactions is considered as a first order reaction. Decomposition of H2O2 or decomposition of N2O5. See, N2O5 decomposed to get what? 2NO2 plus half O2, like that. Mostly only one reactants are involved, no? That is considered as a first order reaction mostly. Okay, or you know, radioactive disintegration. It's very important example. Radioactive disintegration means any radioactive element itself decompose to become radioactive elements. Mostly it's unstable. Then only it's itself decompose to become stable. Okay, until it gets stable molecule, it is going to decompose. Okay, all the radioactive disintegration is also example for first order reaction. See, radioactive disintegration, radioactive disintegration. Okay, so here I will give an example. Radium, you know, Ra, disintegrate, become radon. Okay, here you know, in case of radioactive disintegration, you must know the atomic number and mass number. Okay, so here atomic number, you know, 88 to 26. Okay, radium becomes radon. It becomes here one particle is obtained. That particle is called alpha particle. Alpha particle nothing but helium is called what? Alpha particle. Okay, you know, alpha particle's weight is 4 gram. Then only we are giving the symbol for helium. Okay, that weight is 4 gram. Which element is having 4 gram? Helium is 4 gram. Then only we are giving the symbol. Okay, then you know 88, no, here 2 has gone. So it becomes what?
86.
Are you following? 86. 226, no? 4 has gone. Remaining what? 222. Are you following? Understood? Okay. So all the if you have only one reactant means it's considered as what? Only one reactant involved. That is considered as what? First order reaction. Understood? Just right. Mostly decomposition reaction is considered as a first order reaction. Simple one. Remember the examples. Okay. Decomposition of hydrogen peroxide is a dash type of reaction, they lost like that. Okay. Read down. Understood? See, this reaction depends upon initial concentration of the reactant. But here, even though we are taking the reactant, the reaction will not start. It needs some factor, temperature, pressure, or catalyst. Okay, so then only the reaction going on. That's why it's called what? Zero reaction. Okay, same thing. Here itself going on. If you take the hydrogen peroxide itself decomposed to get H2O plus O2. But here we are taking one reactant. It needs some catalyst. Okay, so right. First write the definition. It does not depend upon the initial concentration of the reactant. It does not depend upon the initial concentration of the reactant. Initial concentration of the reactant. Okay. Even though we are taking, reaction will not going on. Clear? Understood? The best examples, unless teacher, the students will not study. No? If you have teacher, okay, if you have, if the teacher make you to, or the teacher, in presence of teacher only, the students will study. We have different kind of students like that, no? Okay, some students can study own, some students need some teacher, okay, or then only they can able to study. That kind of reaction is called, that type of reaction we can think, okay. So in presence of catalyst only, reaction takes place. Otherwise, it will not taking place. The reactant is present as it is, okay. No reaction takes place. Understood? Okay. Example, best example, here also decomposition. Decomposition of ammonia, okay, on platinum surface. So who is the catalyst? Who is the catalyst? Platinum is the catalyst. Okay, if you have catalyst means the reaction, the decomposition taking place. Otherwise, if you not put any platinum catalyst, ammonia is present as it is. Okay, understood? So it needs some platform. Okay, on the surface of platinum only the reaction takes place. Understood? Okay, likewise here, just write one by one. Decomposition of HI. These are all examples given, directly is given in our textbook. Decomposition of HI on gold surface. Understood? This example already I gave. Photochemical reactions of H2 and Cl2. Are you following? See? Without this, reaction will not take place. Without this, reaction will not take place. Here what? Photo, without light. Photon, I told you no. Without light energy, if you take these two molecules, they won't react. In presence of light energy only, the reaction taking place. Okay? So it needs some factor, that's called what? Zero reactions. Understood? Okay, simply remember all this, okay? Okay. Are you following? Okay. Here we have, next one is, first I told you definition, next one example, remaining is very, very, very important. See, rate constant. So derivation and all they won't ask. You must remember the solution to that. Okay. What is rate constant? The symbol is what? K. We have rate constant for first order as well as zero order. Okay, just listen. K is equal to 2.303 by T log of R naught by R. Understood? K is called what? Rate constant. T is called time. R naught is called initial concentration. R is called remaining concentration. Understood? Okay. Just remember, first order reaction, what's the rate constant formula? Zero order reaction, what's the rate constant formula? Here, what's the half-life period? Like that. It's not, you just remember, it's enough. Okay. So, where K is what? K is what? Rate constant. T is what? Time. This is very important. R naught is what? Initial concentration. Understood? What is R? Remaining concentration. This is very important. Remaining concentration. Understood? Just write one by one. It's enough. The formula is enough to calculate or to do any sums. First, I complete all the importance in first order reactions. Okay, then we can do zero order reaction. Okay. First order reaction very important, compulsory. We can get at least one question from here. First order reaction. Okay. Okay, understood. Okay. Are you following? Formula, just remember, you derive the formula in 12th standard. Okay. It will be asking 5 marks, you know that. Okay. K is equal to 2.303 log of R naught by R. Understood? Okay. Then, next one is half-life period. You just write one by one. This one, half-life period. What is half-life period? Next one is, half-life period. What is the representation? How to represent this one? T, isn't it? I heard about this one, T off. Understood? Half-life period. Okay. What is half-life period? If you have 500 gram, when it becomes 250 gram. If you have 500 gram, when is going to become 250 gram? That time duration is called what? Half-life period. Okay. Time taken to complete 50% of the reaction. Simply we can say. Time taken to complete 50% of the reaction. Okay. Don't worry about the initial concentration. It may be anything. If you have 1000 means what? When it becomes what? 500 gram. Okay. That time duration is called half-life period. Understood? Okay. Just write. Time taken to complete 50% of the reaction. Time taken to complete 50% of the reaction is called half-life period. Time taken to complete 50% of the reaction is called half-life period. Understood? Okay. Sure. It has one formula. What's the formula? Tell me. What's the formula? You studied in 12th standard. Very familiar formula. 0.693 by K. It's the formula. Understood? Sometimes they will give K. We have to find out half-life period. Or half-life period is given. We have to find out K. Understood? Just like that. Just remember the formula. 0.693 by K. It's the formula. Okay. Then it has two factors that are also important. What are the factors based upon this one means? T of is inversely proportional to K. Can we say like that? T of is first factor. T of is inversely proportional to K. Are you following? Another one. See, is there any concentration term is coming here? R not R. It's called reactant concentration. It's not coming here, no. Okay. So here, half-life in case of first order reaction, half-life period is independent of the initial concentration. Independent. Okay. Just write like that. Half-life period of first order reaction is independent of initial concentration of the reactant. It's independent means does not depend. Okay. Independent of initial concentration of the reactant. Understood? Reactant. Okay. Now because they will give the half-life period is independent of the initial concentration of the reactant. Half-life period is independent of initial concentration of the reactant. What is the order of reaction? They will ask. Are you following? That case we are going to study. That depend upon half-life period of zero order is depends upon the initial concentration. Okay, that's why it's called zero order, but it is independent. Understood? The half-life period is independent because no R term, no R term. Understood? Then only it is independent of initial concentration of the reactant. That's called in case of zero order reaction. Okay, just remember these two factors very important. Okay, are you following? Oh, right. Then next one is unit of K. Third one, unit of K, very important. Unit of K. So if you want to find out unit of K means here we have one formula, general formula, mole 1 minus n liter 1 no. I remember like this, 1 no, 1 minus n. Just write reverse, n minus 1 per second. Are you following? So we are going to find out unit of K for first order reaction. So n is equal to 1 pound. Okay, this is the formula. You put in box. Understood? All the points are important. Okay. Formula, unit, this is all you put in box. This one you just memorize. What's the unit for that? If you put n is equal to 1, here what? 1 minus 1? 0. Anything power 0? 1. 100 power 0. Anything power 0? 1. Studied or not? 8th standard mathematics is there. Anything power 0, 1. Understood? 1 minus 1, no. Mole power 0. This comes 1. We can leave it. Then again, here also put 1. 1 minus 1, 0. This also leave it. 1. Who is remaining? Per second. So per second is the unit of rate constant of first order reaction. Are you following? Okay. You write like that. Therefore, unit of K per second. Understood? Understood? Next one. Very important formula. Okay, so suppose here, for example, order how to find out? X plus y, very good. Add the powers, no? Add the powers, we can find order. From the unit also we can able to find out. Suppose, you write one problem. Suppose, find order of the reaction. Find order of the reaction if if k is equal to 2.5 into 10 power minus 2 per second. Find order of reaction if k is equal to 2.5 into 10 power minus 2 per second. Oh, what's the order? What's the order? Find order of the reaction if k is, we can find unit, we can find order from what? What's the unit? First order, understood. From the unit we can able to find it. Are you following? Okay, understood. Okay. You just write this side, opposite also just write, then only it will be easy. Unit of k. Zero order also just write. Zero order. What is zero order? N is equal to? N is equal to what? Zero. N is equal to zero means what? Therefore, unit of k for zero order. Tell me. Zero, no? Only mole will come. Mole. Okay, mole. Then zero putting, if you put zero, zero, 0 minus 1, liter minus 1. Understood? Okay. Then per second. Are you following? Mole per liter per second. That's unit of k of what? Zero order reaction. Are you following or not? Okay. Here I'll give one problem. Simple problem. Find order. Find order if k is equal to 2.5 into 10 power minus 2 mole per liter per second. Is a zero order. From the unit we can able to find out. So many methods are there. We have 5 methods are there to find out order. Add the powers one way. From the unit we can find out order. Then from the graph we can find out. I'm going to teach later. From the graph we can find out. Or some data are given. Okay, some values are given. Then if you substitute we find out. So many methods are there. Okay. Nearly 4 or 5 methods to find out order. Understood? So just now we know add the powers, order we can find out. From the unit we can find out. Understood? Okay. So just write the answer. What's the answer? It is a what order reaction? It's a first order. You write first order. Here what's the answer? It's a zero order. Are you following? Okay, right. Are you following? I gave k value, then I given half-life period value, then I gave how to find out the unit of k. Understood? Okay. Then come to right hand side. Right hand side also we can write something. Okay. Right hand side. Finished? Need out? Come to right hand side. Right hand side. Zero order reaction. What is the definition? Definition I gave no already. Definition examples I gave. Yeah. Okay. K only. I should give only from K. No. Correct or not? K value of a period. Make it a difference. Then it will be easy to study both sides. Okay. Okay, don't worry. Or if you want me to write, put the heading, zero order, you write one by one. Okay. What's the k value? Here we have written no k value. What's the value? 2.303 by T log of R naught by R. Likewise, here also k value. Rate constant. Rate constant K. Okay, K is equal to final concentration minus R naught minus R by, it's a formula. Okay, for K. Understood? Just right. R naught minus R by T. It's a formula. That formula is different. This formula is different. Then here also half-life period. Just write one by one. Formula only just memorize. Final constant will be given initial. Okay, it will be given. Initial concentration minus remaining concentration. That's the meaning for that by T time. Okay, you just subtract divided by time means you can get answer. Okay, then half-life period. Just remember the formula only is enough, highly enough. Okay, T half is equal to R naught concentration by 2K. It's a formula. R naught concentration by 2K. Factors. What are the factors? I told you, no? First factor. See, inversely, last time we have studied, T of is first factor, inversely proportional. T of T, both the inversely proportional 1 by K. Then, when the concentration of reactant increases, T of is also what? Increases, directly proportional. Last time we don't have any R naught term. Then I told you, independent of initial concentration, but it depends upon initial concentration. Okay, just right. Second point you write. First point I given. Okay, first point I given. Second point, half-life period depends upon initial concentration of the reactant. Half-life period depends on initial concentration of the reactant. Are you following? Last time no R naught term, then only I told you, but here R naught term is there. Then only I am telling T half of a zero order reaction is depends upon initial concentration of the reactant. Understood? Okay. Now based upon they'll ask to one question. Okay. If it half-life period is depends upon initial concentration means what kind of order? Understood? Okay. It's a zero order. It does not depends means first order. Okay. Understood? The only one thing I'll give, graphical representation. That's very important. Graphical representation. Here both simultaneously write, then it will be easy. Here also graphical representation. Graphical representation. Okay. Here also graphical representation. Okay. See, before study this, you must know this and all. Ln R is equal to ln R naught minus KT. So this will come when you do the derivations. Ln R is equal to ln R naught minus KT. Okay. Here this looks like y is equal to mx plus c. This is a straight line equation. No? Y is equal to mx. This equation looks like y is equal to mx plus c. Okay. Then in y axis I am taking what? Ln R. In x axis I am taking what? Time. X axis I am taking t. Okay. M is called slope. M is called slope. Understood? Okay. So slope, it's a negative slope. Then we have minus, no, then negative slope. So slope is what? Minus k. This only remember. Okay, understood. So if you know this means you can able to see how they will ask means they'll give one graph. Ln r versus t. Ln r versus t means here you must know it is a first order reaction. In this ln r versus t, what is the slope means? Slope is equal to minus k. It is a negative slope. This information is remember. Okay, it's a minus. No, this is, then I am saying it's called negative slope. Understood? Okay. Just write. It's the first graph. Okay. Intercept is ln r. Just ln r naught. Okay. Intercept is also mentioned. Intercept is ln r naught. Okay. Intercept ln r naught. Okay. C is called an intercept. So when you derive the derivations, that time it will come. So I'm taking this one, then equate this one. Okay. So you don't worry about the derivations part. So if you remember, you just memorize this one. Ln r is equal to ln r naught minus kt. Okay. Are you following? Okay. Sometimes they won't give any graph and all. Simply when ln r versus t. Okay. In case of first order reaction, what will be the slope? Slope is equal to minus k. Okay. Or sometimes the value is given. K is this one. So slope, no, the value in that value you put minus. It is a negative slope, you must remember. Okay. Rate constant is 2.5 into 10 power minus 2. Okay. When ln r versus t means, but when you versus these two, it is a negative slope only, you should remember. Okay. Understood? Then next one is next graph. You know that what's the formula for k? Tell me. K is what? K is equal to 2 point. I told you no. 2.3 not for first order action. T log r naught by r. Understood or not? From this I'm going to rearrange this one. See, listen. Kt multiply Kt by 2.303. Okay, is equal to log r naught by r. This is equal to y is equal to mx plus c. Equal பண்றேன். Y is equal to mx plus c. In y axis I am taking what? Log r naught by r. Understood not? Y axis. X axis I am taking t only. This is m. This is called m. You following? Okay. This is called m. Then here also we are getting positive value. No, here we are getting the positive slope. Slope will be going on like this. Okay. Here slope is what? Tell me. The slope. Well, k not minus. This part only. K by slope is equal to what? K by t mx yeah. Mx x only I am taking here. So m is what? M is what? K by 2.303. Are you following? What is a simple one? This will ask in directly in as a problem based question. Understood? So the slope is given. What will be the k? Understood? So when question will be like this: when log r naught by r versus t, slope is this one. What will be k? So the slope formula you must know. Slope is equal to k by 2.93. Okay, do it. Copy that. Finished?
Intercepted.
Here no intercept in this case. Past is no intercept means this is called intercept no. It starts from 0. Intercept no. Last time the graph no I put straight like this no this one. Yeah, this portion is called intercept no. This portion is called intercept. But here it starts from 0 no intercept. Starts from 0 no. Here where it no intercept no space no this value no y value here. So intercept is 0 in this case. Understood? Just write one problem. When log, simply, then only you can able to understand. If log r naught by r versus time, slope is 0.693. Find k. That's all. How to solve? Log r naught by r versus time, slope is 0.693, find k. What's the slope? Formula? Just now I told you, no? Slope is? Slope is what? Just now I told you, before that I told you, slope is what? K by? Log r naught by versus t, what is the slope? Formula I gave. K by? Understood? From this only, you know everything. Understood? 2.303. Okay, slope is given now. We have to find out the k value. So what? Therefore what? 0.693 by, k by 2.303. Therefore k is what? Multiply. You can get the answer. Understood? Just write. Right. Point 693 by 2, yeah, 2 approximately. What's the answer? So method only, just remember, okay, if you know the method, then you know. Zero point 693 into 2.303, isn't it? Okay, 1.59, 599. Okay, it goes on. 1.599. Okay. Okay, right. Understood. Okay. From the graph, we can find out the order of reaction, or from the graph, we can, the we have formula is there. Okay. This formula only, just remember, this is very important. First graph, nothing. Simply, slope is equal minus k. But here, slope is equal to k by 2.303. Okay. Right. Finished? Okay. One more graph I'll give for first order. One more graph. Same thing you studied. What's the formula? Tell me k is equal to, tell me, 2 point, listen, by t log of r naught by r. Rearrange. Then, okay, in different way we can rearrange, that is, 2.303 by t. How to split this one? Log r naught minus log r, no. Can you able to write it like this? Or log of r naught minus log of r. Can you able to like this? Okay. Then r this one, when it comes to this side, what? This side, kt by 2.303. Can I write like this? Understood? You just interchange. It goes, what happened? Log r constant is equal to log r naught minus what? Kt by 2.303. Interchange. Understood? Now it looks like y is equal to mx plus c. Are you following? Now in y-axis we should take what? In y-axis we should take log r. Understood? In x-axis we should take what? T. This only. Understood? Are you following? T only. Understood? In x-axis. Are you following? Then 90, no. Then I put 90 slope. Are you following? Slope, intercept is what? Log r naught. Are you following? See the intercept. Okay. So what's the slope? This only just memorize. Minus. Last time plus. Minus. Understood? By. So when log r against t. So slope is what? Minus k by 2.303. Understood? This only remember. Okay. Do it. Right. Okay. Everything is coming from here, the formula, it's a basic formula, no. Okay. I rearrange. This 3 graph is very important. Understood? Following? Okay. Just remember, memorize the graph. Based on graph, they'll ask some questions. Understood? Okay. Then this also I'll give for zero order action. Okay. Zero order actions we have simple graph only. see the first graph here. I put ln, no, ln means ln, okay. But here r is equal to r naught, only don't put the logarithm, ln a natural logarithm. This will not come. R is equal to r naught minus kt. This looks like what? Y is equal to mx plus c. Understood? Concentration, this is concentration. Concentration of R versus what? T. We get a negative slope. Slope is what? As usual, minus k. This is right, zero direction. This is one graph. Graph 1. Okay. The ln will not come here. Ln will come here. Ln will not come. Okay. That kind of graph will be there. Okay, understood? One more graph we can put. This is somewhat different one based on based on half-life period. I told you what's half-life period. T of is equal to, I told you, no, already given. What's half-life formula for that? What's the R naught, understood? R naught concentration by 2K. Yeah, understood? I'm going to plot this 2. So what happened? T of, I'm taking y-axis. It's not y is equal to mx plus c formula. I'm taking these two quantity. T of versus concentration of R. So this increases, this also increases, no? Directly proportional. Then only the graph going on like this, like that. Understood? When T of increases, R naught is also increases. So put like that. Do. Then one more graph I'll give. Just copy them. This one. Huh? In this case, we don't have any slope. Slope means, positive slope. T of, yeah, okay. No slope for this direction. Y is equal to mx, yeah, okay. X means, okay, we can say y is equal to, you can frame like this. Y is equal to, mx plus c. X means what? X is what? R naught. Very good. Tell me. 1 by 1 by 2k. Okay. Write down. Slope is, we have some intercept 0. We have some slope, but intercept 0. One more graph, but this is not given in the textbook, but you should remember this one. See, different one. See, rate in y-axis, okay. Concentration, concentration of the reactant. Concentration of reactant in x-axis. The graph goes on like this. What is the definition for zero direction? Zero direction definition. It does not depend upon the initial concentration of the reactant. That's the definition. No. So even though when you increase the concentration, rate will be as it is. No change in. Okay. Even though if you increase the concentration, I told you, whenever if you put some factor, then will reaction taking place. That time will reaction take. Otherwise, See, increase the concentration of reactant. It's called concentration. Increase the concentration of reactant, but rate will be no changes in rate. It will be constant. Okay. So this graph is very important. Okay. So they will give some graph. From this we have to find out the order of reaction. Okay. All this remember. Okay. So it's called graphical representation. Are you following? Understood? Just compare and study, then it will be easy. Okay. First order, zero order means very important. Okay. Okay. Then one more thing. The few topics I'll complete. So, rate constant for first order gas phase reaction. Just a few topic I will complete. Gas phase reaction. So it's also first order, but the substance in what? Which phase? Gas state. That's one difference. Okay. So formula only just remember. Formula is what? K is equal to 2.303 by T log of Pi by 2 Pi minus Pt. This only remember. Substance gas state means we are applying pressure. Substance in gas state we are applying pressure. Pi is called initial pressure, total pressure. This is all time, rate constant. Okay, that only remember. Just write. Pi is equal what? Initial pressure. Okay. Pt is called what? Total pressure. Total pressure. Okay. Total pressure. They'll give everything. It's initial pressure, total pressure, they'll give everything. Okay. So then time is also given. So if you multiply, we can get the K value. Okay. So formula just remember. Understood? Okay. That's all. Then the only one equation, Arrhenius equation only I complete. Arrhenius equation and pseudo first order reactions. I will tell like that. What is that importance of Arrhenius equation and pseudo first order reaction. So before that I will tell the pseudo first order reaction. Pseudo first order reaction, just right. What is pseudo? Pseudo means? False, isn't it? Pseudo means false. We have two reactants are there, but the reaction speed depends upon any one of the reactant. Suppose here, for example, A plus B gives AB. Understood? I am taking 10 gram. This is also 10 gram. After 1 hour, this goes on, this becomes 1 gram. This will be 9.95 gram. So after reactions going on, or after 1 hour, it will be 1 gram. It will be what? 9.5 gram as it is. So among the after 1 hour, who is the large quantity? B is the large quantity. Okay. So actually it said it's a second order reaction actually. Because two reactants are there. No, actually it's a second order reaction. In case of second order reaction, one of the concentrations always excess than the other one. That's called pseudo first order reaction. Okay. So one will be as it is. It will not changes more. It will be slightly changes. Okay. So that kind of reaction we can say what? Pseudo first order reaction. Are you following? Okay. So example, just write the definition. Write the definition. um, it is a second order reaction. It is a second order reaction in which one of the concentration of the reactant is excess. In which one of the concentration of the reactant is excess than the other one. One of the reactant concentration is excess than the other one. Are you following? Okay. We are taking initially same amount. After reaction is going on, it goes on, decreases, it will be as it is for a long time. Okay. That kind of reaction is called pseudo first order. Okay. Pseudo means false, no. Okay, meaning you know. Pseudopodia I have studied, no, in biology. Okay. Okay. Examples. Just remember, I am giving 2 examples. Hydrolysis of, just write, hydrolysis of ester in presence of acid medium. In presence of acid medium. Example. Ester means, what's the formula for ester? R COO R. Correct or not? So I'll give one example. See, just listen. Instead of R, I put CS3. CS3 COO CS3. Hydrolysis means what? H2O is added. Acid medium, no. So plus H plus. Acid hydrolysis of ester. Understood? What happened? HOH. What's the product? CH3COH plus what? CH3OH. Are you following? Okay. When we add water to ester, we get what? Acid plus what? Alcohol. Are you following? Understood? So this is the best example for pseudo first order reaction. See here, outright rate law, R is equal to K into 1, 2, 3. 3 reactants are there. Then I put what? K3. This I consider as ester. It's H2O. Are you following? This is called H plus. Actually, it's a third order reaction. But we are saying pseudo first order reaction. How to say means, see, this is a catalyst, ma. I told you. What is catalyst? To increase the speed of reaction. Okay. Suppose if one of the important properties of catalyst is its mass remains unchanged. We are taking 2 gram. At the end of reaction, again 2 gram is present as it is. But slightly its properties will be changes. Mass will be as it is, catalyst. So mass will be as it is means it's a large excess, no? So we leave it. Okay. H2O. For hydrolysis of ester, only few mole is needed. We are taking 1 mole at 55 moles of H2O, but 55 moles of H2O, 1 mole is consumed for this. Remaining is what? 50? 55 as this. So I am telling one value, but so many, only few moles of H2O is consumed for hydrolysis. Okay. Only, so this also will be large excess as it is. This also not considered. Okay. Who is going on changes means ester. Ester only going on changes. Understood? So what? Then only R is equal to K3 dash. I differentiate. K3 dash ester. Are you following? Okay. So K3 dash is called what? Rate constant for pseudo first order reaction. Are you following? Okay. So K3 dash is called rate constant for pseudo first order reaction. Pseudo first order reaction. Just write fast. No. You just remember, hydrolysis of ester is an example of dash reaction. What's the reaction? First you study that one. Okay. This is nothing but how we can get means, number of moles formula, mass by molar mass, no? Number of moles formula, mass by molar mass, yeah? Are you following? Number of moles formula, mass by molar mass, small m. Mass is, it is measured, 1000 gram. By molar mass is water. Understood? So 1000 by, for 1 molarity solution, solvent should be measured in 1000 gram. Okay. So 18, we are getting this one. Okay, so molar water is also excess amount. H plus is also excess amount. This is only going on changes. Then only I consider this only. Okay, understood? The example 2, just mention, need not write all this. Inversion of sucrose, right? Second example, inversion of sucrose. Inversion sucrose, or you just write hydrolysis of sucrose. Hydrolysis of sucrose in presence of acid medium. Hydrolysis of sucrose in presence of acid medium is also an example. Understood? Are you following? Okay. Only on top, finished. Only the formula I will give, just all, simple. Arrhenius equation. Arrhenius equation. K is equal to A into e power minus E of A by RT. It's a formula. K is what? Rate constant. E of A nothing but, what is E of A? Activation energy, yeah, or energy of activation, yeah, activation energy. R is what? What is R? Gas constant, no? T is what? Temperature, okay. A is called what? Frequency factor or Arrhenius factor. Frequency factor. Listen, it's only just remember. You just relate the rate constant and the temperature. Okay. So, you frame one equation, K is equal to A into e power minus E of A by RT. This is a formula. Okay, so here, finished up. Then, if you apply logarithm and all, we are going to get another formula for that. That formula is important. That based upon only they will ask some questions. Okay, so problem. Suppose if you apply logarithm to this, here log of this only just write log K2 by K1 is equal to E of A by 2.303 R T2 minus T1 by T1 T2. This is a formula. Understood? So based upon, so I completed all the theoretical part. Okay. So next class I will give some problem based on this. Understood? Okay. So first order reaction, then formula is based on first order. The problem is very, very important. First order, then zero order is also sometimes they are asking. They didn't ask any. Still the zero order reaction based on problem. Okay. Sometimes they'll ask the zero order reactions problem. then Rn is equal. This is the first one, just relation only. But if they want to ask problem means they'll ask a problem based upon this formula. Okay, this only just remember. Okay. T1 is all if you want me just write. T1 means initial temperature, this is called final temperature, activation energy, gas constant. Understood?